Thanks everyone for coming, and sorry about the little delay on the laptop. But today I'm going to talk to you a bit about using Redis as a way of solving your challenges in deploying models that you've learned through Spark and Spark ML, or actually any other machine learning library. Now, I'm sure a lot of you have heard about Redis and maybe are a bit surprised actually hearing about Redis in this context, because you come to Redis thinking about Redis as an in-memory cache. But actually it has evolved into a multimodal database that allows you to do a lot of different things, and one of those is serve predictive models out of various training systems. So I want to start a bit though at the back up and what are we trying to do really? What are the business problems that we're trying to solve, and why do we want to use machine learning? And for most people, what we're trying to do is teach a computer through example an algorithm that is just simply too complex for us to program. There's many different techniques, but ultimately these decisions and these things, these artifacts that we're trying to build are just simply beyond our ability to actually directly program, and we need ways of solving these problems that aren't done through direct programming. And now I'm sure this is a review for a lot of you, but when we look at machine learning problems and the things that we're trying to deploy, they generally break into one of three categories. Some type of classification problem. So you're picking one out of a set. Maybe this is labeling mail versus spam. Maybe you're trying to add auto tagging to something. Another class of problems that we look at frequently is regression, is where you're trying to score or rank something. The final set of problems tends to be clustering problems. So we're looking to find similar items, maybe cohort detection. And a lot of times you'll see like k-means clustering or hierarchical clustering here. So a lot of us know how to build this. Supervised learning, example, training a spam classifier. We know how to build this box. We show it a bunch of examples of spam. We show it a bunch of examples of mail. And we know how to build this box to train and learn the difference between these two things. And ultimately, when we deploy this, we want to build another box or a machine that basically takes in unlabeled items and splits them up, in this case, into spam or mail. The question becomes, though, is how do we build these boxes? What are the techniques and the tools and the frameworks that we want to use to build these boxes? Well, when we look on the learning side and the generating these statistical models, there are a lot of frameworks available. There are tons of frameworks. Of course, us being here at Spark Summit, Spark ML Lib is really one of the places where we look for it. But people have invested a lot of energy in the training side of this problem. But what do you use to build the deployment side? The predictive engine that takes the unlabeled examples and returns you a result. Very little has actually gone into building off-the-shelf frameworks for this. And that's where we sort of saw a need and a place for Redis to come in and fill this. Because if you think about building high performance reliable services is not an easy thing to do. We've all built a custom application. We've all deployed something that was kind of a one-off for that service that sits in the corner and drives your operations people crazy. We've all done it. We don't build heavy administration tools around it. It often is not very feature rich. It's something that we do very quickly, and then it sits over there in the corner until it falls down, and then maybe we add another feature or do something to make it a little more robust. Ideally, we would just be able to pull a very common off-the-shelf tool to deploy any number of these predictive models that we would want to use in a production training system. And that's where Redis ML comes in. If you think sort of your typical Spark application structure when you're talking about machine learning, you have your Spark and your training pipeline ultimately ends up with generally a Parquet file system, Parquet file in the file system. And then someone builds a custom server or a custom app that your client app or your website connects to make real-time decisions. What we envision and where what we've built Redis ML for is essentially to change this architecture a bit. You keep the Spark training, but once you learn those models, instead of serving them out of a custom application, you serve them out of Redis ML. And you can actually pull in additional models from other training platforms as long as they're a statistical model that Redis supports. Now, for those of you who might be less familiar with Redis, what is Redis? Redis started out as a remote dictionary server, and it's a NoSQL database. It's all run in memory. One of the things that's very different for Redis, or where Redis differentiates itself from other NoSQL databases, is that the way Redis models databases through data structures that you're already very familiar with. So things like strings and hashes, linked lists, hyperlog log, sets. All of these things that we find as operations and libraries within our programming libraries are things that Redis provides to you as a server, and data that can be shared among various clients connecting to it on the network. Now, when Redis models these data structures, it provides semantic modeling of these data structures and semantic operations on these data structures. And what I mean by that is you aren't serializing some JSON structure and writing it out to memory. You aren't sending some binary form of a class. You're actually working with a set. So the operations that you send to the server are things like add this element. What is the length? What is the number of members in my set? What is the length of my list? And the Redis model looks something like this. You have a key which maps to one of these data structures. Now, since Redis 4.0, and all of this that I'm talking about today is available in open source Redis, any C or C++ program, also any Go or Rust program, can be run as a Redis module. So you can do things like add new data structures, add new functionality, add commands to existing data structures, and basically take advantage of Redis as a framework that your operations team probably is already familiar with and may have already deployed, common clients in any libraries, and you can start adding new functionality. And what the Redis ML module did was take advantage of this to add predictive, parameterized statistical models as a native Redis data type. So the current version of Redis ML supports the ability to store tree ensembles, linear models like a linear regression or a logistic regression on Redis as a Redis data type. And when I say Redis data type, that means it takes advantage of all the services of Redis. So you can do replication. So you can set up multiple read-only replicas and coming off a master if you need to scale up. You take advantage of all the data space. So if you want to do A/B testing, you can actually name keys that point to linear regression as two different key names. It also supports matrix and vector operations. And in fact, neural networks and k-means clustering is supposed to be coming out in about the next probably 4 to 6 weeks. So it's an active development. You can actually go to GitHub. You can see what we're doing. You can see the code. You can add pull requests. You can modify what we're doing. You can actually contribute new models if that's interesting to you. So one problem I wanted to talk about and to see how Redis adapts to this is the random forest model. And random forest is a collection of decision trees. It supports classification and regression problems. We're going to look at it as a classifier because that's really what Redis is designed to use it for. Interior nodes are basically splitter nodes or rules. And you work your way down the tree until you get to a leaf. And the tree leaf determines the actual classification. Now this is a set of multiple trees. Each tree is evaluated independently, and then you take basically the majority classification wins. And this is actually, you see this in a particularly classic ML problem, learning problem when you're first addressing trees is the Titanic survival problem. So you take the Titanic passenger data, which is encoded as a feature vector. You apply some type of learning algorithm to that data to determine the trees and determine the rule sets. There's a lot of different algorithms that can be used to actually infer and determine what trees, and they have various different properties. There's ID3, there's rpart, there's cart. But any of these algorithms can actually generate a tree, because at the end of the day, the tree is a model or a data structure that anyone can evaluate. On the left here, we have an example of one such tree that would basically evaluates between survival and a person perishing. And you'll see how at each interior node it splits. Here's an example of that extended to a random forest, and you can see how various different rules are applied to that. And at the end, we'll look at a demo actually of running this, but we have 2 sample passengers who actually, and we want to know what they would use. And actually, I'm going to switch to the demo right now because I think it's illustrative. Let me pull up this and, oops. Is that large enough so people in the back can see? So we'll run the Titanic survival predictor here and we'll build it. So these are pre-loaded a pre-learned tree. And you'll see here all of the Redis commands to actually add these trees to Redis. And I can jump over here to my Redis CLI and do a keys command here and show all the different keys. So in this instance, I've actually loaded into Redis 3 versions of the tree. So a forest that consists of each of the 3 trees that I trained previously, and then an actual forest with all 3 trees. Now you can see here, these rules are not really set up to be human approachable. This is really machines talking to other machines. And so you can see here an example of the add command where we're constructing here tree 1, and you'll see these dot notations for paths in the tree. You'll see types, and then you'll see the whole specification of the path. Now, if I run this, it's predict, you can actually see using the features of John and the features of Matthew, which one is likely to survive the Titanic and which one is likely to perish. We'll look at John here. Actually, 2 of the 3 trees say that John is going to survive. So our forest will overall predict that John survives. For poor Matthew, unfortunately, all 3 trees suggest Matthew will not survive. So our forest predicts that he does not survive. But again, you could learn this in any model or any training system as long as you represent the underlying statistical model of a decision tree. And just here's an example of the Redis syntax for setting up these things. Again, with the adds, you set up the tree all at once and the runs. So Titanic is great, but most of us really don't make a living off of the Titanic anymore. Why would I want, what motivates this in the real world? Well, one of the places we've worked with customers is on ad serving. And we had a customer with a very extensive ad serving need. Low latency, large number of trees to develop. And what we were able to do was using Redis, and in our case we used Redis Enterprise with them. Again, this is also available in open source. Is cut their ad serving infrastructure down by about 97%. They're running on AWS. And for any of you who pay the AWS bill, you'll know that being able to reduce it by this month is a very significant savings in underlying infrastructure costs. And that's where we're positioning, or why we developed Redis ML, is a way of making it easier to build reliable and robust decision side deployment of statistical models. You train with Spark. In the case of Spark, we actually provide another open source module that's actually a connector between Spark and Redis that automatically loads any library or any models that you've trained into Spark into Redis, so you don't have to build any of that code. We reduce your, essentially your resource and serving costs, and we give you something that's very, very scalable. Redis is extremely robust. It has a great open source community around it, and clients in every language. Any client, any language you want to use, be it Python, be it Scala, be it Java, you can find a Redis client. And best thing is that your operations team is probably already using this in the active side of either your site or your applications. And so you're giving them a tool to basically build this off-the-shelf predictor that they're already familiar with, that they understand how to scale, how to deploy, and how to keep it up and running. So that's why we came up with Redis ML. Again, both Redis and Redis ML are available in open source. You can go out and look on GitHub and see what we're doing with Redis and what we're doing with Redis ML. So thank you very much. Does anyone have any questions regarding Redis ML or Redis in general? Yeah.
Yeah, so the matrix and vector operations, do they take advantage of any GPU hardware if you have that running on?
Right. So right now they do not. Okay. We use on I want to say I can't think of the name. The Blast library, I believe it is, for matrix operations. But we aren't set up to take care of to run on GPUs right now. In general. The matrix operations are there. I do not think they are as robust as the linear models and the tree models. So I definitely encourage you to take a look at it. It's zero cost, zero investment to do this. But I would really look at the matrix operations very carefully before going too far down any type of project.
Cool. And then one more, and I may have missed this on a slide. How do you export your model out of Spark into Redis ML? I didn't quite catch that.
So for all of the statistical models that we support, there's essentially commands that as you learn whatever the parameters are. So we'll take an easy example, align. Align is basically whatever n-dimensional parameters plus a slope. So there's a command to load that is basically you specify all of the line parameters in your slope in order, and you give it a key name. In the case of Spark in particular, we actually have a module or a connector, if you will, that you essentially just point it at the model. It translates it into the Redis commands to load that model into Redis.
Okay, so they're predefined models that.
Yeah.
I got you.
So model-wise, right now, like I said, what we support is linear models, so regression and logistic regression, and then the trees. Those are the three strongest ones. There's also then matrices and neural networks, and k-means clustering is coming. K-means you can actually see right now if you actually go to GitHub and pull the code and build it.
Cool. Thank you.
Mm-hmm. Another question over here.
I have a couple quick questions. The first one is, what's the support about model versioning?
Sorry, could you repeat
model
that?
versioning, what's the support of?
Mm-hmm. So in terms of versioning your model, whether it's just evolving it or if you want to do A/B testing, all models are basically represented or named, so they have a key name. So you can basically use any sort of versioning scheme you can fit into a key name. Redis in particular doesn't provide any infrastructure or framework around A/B testing or versioning, but you can store each version. You can basically have a model named, housing predictor V1, housing predictor V2, and then switch between the models when you need to.
Essentially a metadata when you export your model from the pipeline.
Sorry, could you repeat the question?
So my understanding, this model versioning, the support comes from, when I export my model from the pipeline. So essentially it's a metadata that I can set over there.
Yeah, I believe so. Maybe I'm having trouble hearing you, so maybe we can just talk in person up there. But I think your understanding is that it's really name-based versioning, and then your client selects the appropriate model.
Okay, the second question is that what's the support if I use the AWS Elastic Cache? So what is the process look like, to deploy Redis ML into?
Right. So Elasticache right now does not support the Redis module system. So for those of you who may be less familiar with the Redis ecosystem, Elasticache is Amazon and AWS's version of open source Redis as a service for their platform. Right now, AWS, I believe, is roughly supporting Redis version 3-ish, like 3.2 with Elasticache. Modules require 4.0 and greater. I don't know right now what Amazon's plans are in terms of adding model support. Obviously, for Amazon being a cloud provider, they can't just give you the ability to load arbitrary code and execute it. So I honestly don't know what their plans are right now around that. But you basically would have to look at, like my company, Redis Labs products or open source.
Okay, thank you.
Thank you.
Are you planning on supporting more connectors for different frameworks? For example, let's say you export a TensorFlow model, which is like a custom serialized format, and it might have like 1.2 million parameters, and you just point to that model. And
sorry, could you repeat your? I'm sorry, I'm having problems hearing you.
I'm asking, are you planning on building more connectors for different kind of frameworks? For example, you build a TensorFlow model and you export it in a custom serialized format, which might have 1.2 million or like millions of parameters, which so that you can just export, like point to an exported file and it just.
So right now we're focusing just on Spark.
Okay.
There is unsupported code available to do scikit-learn, but we don't have any connector plans beyond that right now.
Okay, all right.
Yeah.
Yeah, so my company has a use case where we not only want to serve up the results of our analytic models, but we also want to allow our end user to use a BI tool like Tableau or Spotfire to, once they get a classifier and it says, hey, this entity is predicted to be of interest with a certain confidence, we want them to be able to drill down and pivot and look at the data we have on that entity. Would Redis serve well as a caching mechanism for a large transactional data set, say a few 100 million records, to sit behind a Tableau dashboard? So once our analysts have seen, this entity's of interest, I want to now drill down and research and do some visualization. Would Redis work well at serving big data sets like that?
Yeah, I think where you're going to find the challenge is everything Redis serves is in memory. So obviously memory is one of your most expensive infrastructure costs in terms of building out a box. I sort of want to give you a guarded yes, because it's yes, there are ways to also reduce your memory footprint. Redis proper, without even the Redis ML module, is probably the biggest use case is actually caching data for other systems. I don't know if there's any direct connector with Tableau in terms of Tableau automatically caching the data in Redis, but it's quite likely there is. If you do want to build custom stuff, it'll be great for caching. It's really then the challenge is how big does the data set get and how do you balance off the cost of memory versus performance.
Got it. So the Redis data is always in memory.
Yeah.
There's no, say, a Parquet backend or something like that where it gets spilled to disk.
Yeah. So Redis has a durability system so that your data can actually be saved to disk for recovery purposes. Excuse me. But all serving is done out of main memory.
Got it. Okay.
Excuse me.
Thank you very much.
Thank you. Any other questions?
So I believe you said there's a connector to save the model, Spark model in Redis. Now, what about the scoring piece? Is there a similar connector to do scoring or inference from the saved model?
Not right now.
So,
Sorry.
so in this case, how would you do the scoring? Actually, I'm just trying to hard to conceptualize.
So the scoring would actually come from a client connected to Redis and speaking the Redis protocol.
Okay, but typically in Redis, you're just providing the key to read the thing, right? So,
Oh, so one of the things with with the module system is that it allows you to actually add commands to evaluate.
oh, I see.
So the Redis ML module, what it basically does under the hood is make parameterized statistical models available as a native Redis data type. And so what you do, say in the case of a linear regression, you send, like a tree, for instance, you send it a run, you give it the key name and the feature vector. Then on the Redis server, it actually goes and evaluates that feature vector against the model that's stored at that key. So if you wanted to have n models, you could
I
put
see.
them in each key.
And the feature vector has to be in the exact same format that I would have provided if I was running that model within Scala Spark code, right?
Right.
Okay. All right. Thank you.
Awesome. Any last questions? Happy if you don't want to ask in front of everyone, or if you have other questions, I'm happy to sort of take them offline. But thank you all for coming and staying. I know it's very tempting with lunch, but I appreciate it. Thank you.